Hi, welcome to the video on implementing decision tree. By the end of this video, you will be able to implement decision tree model using sklearn and briefly explain underfitting and overfitting. Now that we know the logic behind the working of the decision tree and all the associated characteristics, we will now look at the implementation of the decision tree for a classification problem, just like we did for the linear and logistic regression. As always, we begin by importing the necessary libraries and the dataset. We have used the churn prediction dataset, which we have already seen during the logistic regression implementation. The next step is to do the basic required preprocessing of the data, which includes separating the dependent and the independent variables to variable x and y, scaling the dataset, and finally forming a test and a training set for both the dependent and the independent variables. Although in the case of decision tree, we do not explicitly require to scale the dataset as it is not distance dependent. Therefore, you may choose to skip this step. The next step is to import the decision tree algorithm from the sklearn library. In this case, we will be importing the decision tree classifier as DTC and create an instance classifier of the class DTC. If you recall, this dataset was imbalanced and therefore we are setting the class weights as balanced so that each class gets equal significance irrespective of the uneven distribution of classes. Now the next step is the obvious one. We use the classifier instance to call the classifier fit function and pass the training set xtrain and ytrain as its parameters. In the next line, we will first predict the values of the training set itself. For this, we will use the classifier.predict function and pass the xtrain as parameter to predict the corresponding values and store it into predicted values variable. The next step is obviously to find out the performance of the decision tree model. The fastest way to find out the performance of the model, as we have seen before, is to print the classification report of the decision tree. So, we start by evaluating the model over predictions on the training set itself. For this, we will use the classification report function and pass the ytrain and the predicted values using the training set and run the cell. Aha! The decision tree classifier is giving a perfect score of 1 in every metric. We can clearly see that the decision tree did a splendid job in learning from the training dataset. Now, let's find out the model performance over the test set. For this, we will again use the classification report and pass the test set and the values predicted over the test set this time. Let's run this cell. Although the results are not bad, we certainly did not expect these results after looking at the performance on the train set. The precision and recall scores are far from ideal. So what happened here? Why did the model perform well with the training set but gave mediocre results with the test set? To understand this, we will have to understand a real-life example, and for that, we will go back to school days. Consider a math class setting consisting of students and a teacher. Let's name the students as A, B and C and discuss their behavior one by one. Let's begin with student A. His hobby is coloring. He does not like math, like me, and hence he is mostly not interested in what is being taught in the class and therefore does not pay much attention to the teacher. On the other hand, we have a student B who wants to be the best in class. He focuses on memorizing each and every question being taught in class instead of focusing on the key concepts and learning the problem-solving approach. Lastly, we have the ideal student C of the class. Her hobby is learning new things. She is purely interested in learning the key concepts and the problem-solving approach in the math class rather than just memorizing the solutions of the classwork. Now we all know from experience that what happens in a classroom. The teacher first delivers lectures and teaches the students about the problems and how to solve them. At the end of the day, the teacher simply takes a quiz based on what she taught in the class. On the other hand, she also takes monthly tests of the same subjects where the students had to face new questions which were new to them and never taught in class. So let's try to discuss what happens when the teacher takes a quiz at the end of the day. Now, as we already know the characteristics of the student, we can clearly agree with the results of the class test. Student A, who was distracted in his own activity, simply guessed the answers, got approximately 50% marks in the test. On the other hand, the student who memorized each and every question taught in the classroom was able to answer almost every question by memory and therefore obtained 98% marks in the class test. For student C, she actually solved all the questions using the problem-solving approach she learned in the classroom and got 92% of the marks. By this class test result, we can clearly infer that the student who simply memorizes everything is scoring better without much difficulty. But now, let's also look at what happens during the monthly test when students have to face new unknown questions which are not taught in class by the teacher. In case of student A, things did not change much and still randomly answers correctly 50% of the time. In case of student B, his score dropped significantly. Can you guess why? This is because of the fact that he always memorized the problems that were taught in the class, but this monthly test contained questions which he had never seen before, and therefore his performance went down significantly. In case of student C, the score remained more or less the same. Why? Because she focused on learning the problem-solving approach and therefore was able to apply the concepts she learned to solve the unknown questions in the monthly test and therefore keep her scores consistent. Now you must be wondering how this example relates to the problem which we encountered during the test and train scores of the decision tree classifier. So let's work on connecting this example with the decision tree classifier that we built a while ago. Firstly, the classwork and class test resembles the training data and the prediction over training data itself respectively. On the other hand, the monthly test represents the test set from our data which we keep aside before we train our model. Now if we recall that decision tree classifier gave a perfect score over the training set but struggled with the test set. Comparing that to the student examples that we just discussed, the classifier establishes an analogy with the student B who tried to memorize each and every question in the training set. Similarly, our decision tree classifier tries to learn each and every point from the training data but suffers radically when it encounters a new data point in the test set as it is not able to generalize it well. The situation where any given model is performing too well on the training data but the performance drops significantly over the test is called the overfitting model. For example, the decision tree classifier which we just built. On the other hand, if the model is not learning and consistently performing poor over the test and train set, it is called the underfitting model. Example of this situation would be building a linear regression model over the non-linear data. And if the model is performing equally well over the test and train set, then it is called the best fitting model. Now you might be wondering, we simply made a decision tree classifier. How did it end up overfitting? Why did this not happen when we implemented the linear models? Let's explore the answers to these questions in the next video.